Okay, so let's start with part 2 here. So again, what we're doing is we're solving our inequalities, and so what we need to do is we need to get the part with x on this, in this case, the right side. So to get rid of the other parts, we're going to subtract 8 from both sides. When we do that, we get 3 is greater than x over 2. Now, like we saw in part 1, what we had to do is we had to multiply by the denominator to get rid of it, because 2 divided by 2 is 1, and so that leaves us x. But if we multiply that on one side, we have to multiply it on the other. So 2 times 3 is 6 is greater than x. So now we've solved it. Now what we need to do is go over here, and so that's our 6, and x is less than 6. So less than is going to be an open circle, and it's less than, so it goes that direction. And if we plot that in interval notation, that gives us from negative infinity to 6 with the parenthesis because of the open circle. And so we have our interval notation, our graph, and our solution here. Now the next one, we have parentheses on both sides again. So what we need to do is distribute. And so we're going to do that first. And so that's going to give us a minus 4. Then we have a plus 5p, then plus 3, greater than or equal to. Here we have a minus 16, then plus 10p. All right, so we have the two numbers here. So minus 4 plus 3 is a minus 1, plus 5p greater than or equal to negative 16 plus 10p. Now, there's more p's on this side than are on this side, so I'm going to subtract 5p here, so I end up with positive p's when I get done. And then I'll add 16 to both sides. So when I get done, I have here, it looks like 15 is greater than or equal to 5p. So divide by 5 to solve for p. And that gives me 3 is greater than or equal to p. Or if you read it from the variable to the left, p is less than or equal to a 3. So that's our solution. Now if we graph that, here's our 3, less than or equal to that, so it's going to be a closed circle and everything that direction. Okay. Now, what does that give us for interval notation? Well, we're going to go from negative infinity to 3, and it's going to be a bracket because of our closed circle. So we've got the interval notation, we've got our graph, and we have our solution above there. All right. Now we're going to work with tripartite. Now, while it wasn't mentioned in the initial pieces, when we have this, it's an and. And so with and, what that means is it has to include both of them. So we're going to have two things, and one might go from that direction to that direction, and the other one might go from this point here maybe and go that direction. And the and is going to be where they basically overlap. Okay, so that's where it's going to be true, and so that's going to be the solution. And so anything, if it is not overlapping, those pieces are not part of the solution. So let's start looking at this one first. So how do we do that? Well, we need to get k by itself, so we're going to subtract 8 here. Now remember, with the tripartite, we need to get it on all three parts. So we're going to subtract 8 here, and we're going to subtract 8 here. So 11 minus 8 is 3, that's less than k. Then we have less than or equal to, 12 minus 8 is 4. And so if we plot that now, we have a 3, we have the 4. So k is going to be greater than 3, so it's going to be basically going this direction. Then we have k less than or equal to 4, so we're going to have a closed circle going this direction. And now this is the and. So what are the pieces here? So we're going to have basically between here and here. And so really it's just going to be an open circle from here to the closed circle from here, and that is going to be our graph, really. That's all that's going to be graphed. So the rest of these pieces out here and pieces out here are not going to be. And so this is going to go from a 3 to the 4, and then the 4 is a bracket and the 3 is a parenthesis. So that's our interval notation. This would be our graph, and this is the solution. Now what about this one? Well, we're going to have to do the same thing. We're going to have to get the k by itself. In this case, it's going to be an m. And our first step will be get rid of that 8. So we're going to do the same thing we did last time. We're going to subtract 8 on each piece. Now, minus 4 minus 8, that's a minus 12, less than minus 3m. Remember, that minus stays with it. And then that's going to be less than or equal to 11 minus 8 is going to be 3. Now we need to divide by a negative 3. Now the key is, remember, when we divide by a negative 3, we have to switch those signs around. So now what we're going to have is 12 divided by 3 is going to be a 4, and it's going to be positive because negative over negative is positive. And now that's going to switch to greater than. Now we're going to have m because negative 3 divided by negative 3 is 1. And then it's going to be greater than or equal to because that switches around. And then 3 divided by negative 3 is a negative 1. All right, so now let's see, what do we have here? We have, this is our 4, this is our negative 1. So here it says m is less than 4. So it's going to be an open circle going that direction. And this one says m is greater than or equal to a negative 1. So we'll have a closed circle going that direction. And if we plot it underneath, it's the intersection. And so that's going to go from a closed circle at negative 1 to the open circle at 4. And so that gives us a bracket negative 1 to 4 and then a parenthesis. Okay. And so that would be what our solution would be for this tripartite inequality. All right, now we have fractions in here. Well, with fractions, all we've done in the past is we multiply by the denominator. And so here we would multiply by 9 because 9 divided by 9 is 1. So that leaves x there. But we also have to multiply by 9 here. And we have to multiply by 9 there. So what do we have? Well, 0 greater than or equal to x greater than or equal to a negative 9. So again, let's plot what we have. All right, so negative 9 somewhere over here, 0 somewhere over here. And again, units don't really matter. We don't have to mark them all off. We just choose a negative 9 and a 0 spot and say that's good, and units in between don't matter. And so now it says x is less than 0, or equal to, I should say, less than or equal to. And so if we do that, what we have is I have a closed circle going that way. And here it says x is greater than or equal to a negative 9. So we'll have a closed circle here going that direction. And now we just have the parts that overlap. And so that's going to go from a negative 9 all the way up to 0. And so that's going to go negative 9, 0, and have brackets on both ends because we have the closed circle on both ends due to our greater than or equal to. Now this one looks pretty much the same as that one. So what do? Well, we're going to multiply by 8 on each piece. And now what does that give us? Well, that gives us 8 less than or equal to p less than or equal to 0 because 8 times 0 is 0. So that's our solution there. So what does it look like over here? Well, here we have, let's see, that's 0 there. Let's say that's 8 there. So it says p is greater than or equal to 8. Well, greater than or equal to 8. So that's going to be going that direction. Now this one says p is less than or equal to 0. Well, p less than or equal to 0 there. Now where do they overlap? Well, they don't. And so because they don't overlap, this means there's no solution because they have to overlap to be able to get the pieces that match. And so, like this one, it's overlapping from here to here. Those pieces out here don't count, and it's only going from the negative 9 to 0. Now here, there is no overlap, and so therefore, our solution is basically no solution. So even though we solved it at that point, that's not going to give us the actual interval notation because our interval notation basically is going to be no solution or the empty set. Okay, so hopefully that will help you with some of the homework.